Hello, lovely people. How are you doing? So here in the run-up towards the further maths GCSE papers, I thought I'd do some 5-a-day problems. Let's get right into it. Now, of course, you can pause the video and have a go at the questions beforehand, or you can just enjoy the show and listen to my thought process as I go about doing these questions. So the first question says to solve 6y squared plus 4 equals 13 minus 3y plus 4y squared. So I can see this is a quadratic because of the y squared. So the first thing that I'm going to do is make it equal to 0. So if I take away 4y squared from both sides, I get 6y squared take away 4y squared is 2y squared. If I add 3y to both sides, I get plus 3y. And if I subtract 13, I do 4 minus 13, which is minus 9. And that equals 0. I'm now looking at this and wondering, can I factorize this in some way? So 2 times minus 9 is minus 18. Are there two numbers that multiply to give minus 18, but add to give 3? Yes, there are. 6 and minus 3. So I'm going to use my ultimate factorization hack. Please check out that video if you haven't already. And it's going to be like this. 2y plus 6. 2y because it's 2y squared. And 2y minus 3. And because expanding this bracket would give me 4y squared, but instead I want 2y squared, going to divide it, straight line, by 2. And that is equal to 0, of course, because it's still an equation. And then in simplifying, I'm able to divide this first bracket entirely by 2. So that becomes y, because 2y divided by 2, plus 3, because 6 divided by 2, multiplied by 2y minus 3 is equal to 0. Okay, and that means that either y plus 3 equals 0 or 2y minus 3 equals 0, which means that y equals minus 3 or y equals 3 over 2, adding 3 and dividing by 2. First question done. Next, how many odd numbers greater than 50,000 can be formed from the digits? Okay, with no repetition of any of the digits. Okay, so first things first, we can see that we've got 3, 4, 5 digits. So if our number is to be bigger than 50,000, the first digit has to be one that's greater than 5. Okay, so in our first option, we have how many different options? We could put the 9 there, we could put the 8, and we could put the 6, because they're the ones that are greater than 5. Any other number, and you'd form a 5-digit number that is smaller than 50,000. So we've got 3 different options there. Okay. 2, 3, 4, and 5. So the other important option is the one that we have at the back over here. So we have to have it end in an odd number if it's to be an odd number. So out of 4, 6, 8, 9, and 0, how many of them are odd? Well, it's just one of them. It's only the 9. So we know for a fact that this last digit has got to be a 9. There's no other option for it. Because if it ends in a 4 or a 6 or an 8 or a 0, it would be even. And the question asks how many odd numbers greater than 50,000 can be formed. So that actually means that in our first option, where I initially said we could put 9, 8, 9, 8 or 6, that wasn't actually correct. Because if 9 is one of the options and it's the only one that can go in the last option, and we can't repeat the digits, that means that we only have 2 options. So again, you're watching me think and you're watching me do things how I do them. Okay, so we've got 2 options. And then we've got the rest of the 3 digits that can go here. So as an example, In fact, no, I'm going to leave it like that. So I've got two options for what can go in the first option, and of course, one option down here. I'm going to put one option. And then in the next bits, I've got three options. And then two options. And then one option. So three options because we had three numbers remaining after we pick one of the options that can go here. And we pick one of the options that can go here, i.e. the only option. So even though there are 5 digits and there are two options for the first one, you can physically only put one number at a time. So after you put the number in the first digit and in the last digit, you then have 3 left, which is why I put 3 for the third one. And then after you pick one from there, you've then got 2 left. And then after you pick one from there, you've got 1 left. And now it's just multiplying it all out. So it's 2 times 3 times 2 times 1 times 1. So 2 times 3 is 6, times 2 is 12, times 1 is 12, times 1 is 12. Remember, you don't need to know what the actual digits are, what the actual numbers are. Just know that that is the number of options that you have. Okay, next I'm going to change color. Let's go for purple. Right, we're simplifying this. Well, this is quite nice. It's division, right? When you divide by a fraction, it's the same as multiplying by the reciprocal. So what I'm going to do is write it as x squared plus 8x minus 20 over x squared minus 9. Change that division into a multiply, and then the reciprocal of the second fraction, flip it, whatever people call it. Really, it's the reciprocal, but it's okay. X squared plus 3x at the top, and x minus 2 at the bottom. I'm going to change colors because there's going to be a lot of writing here. Right, now, a lot of people might be tempted to multiply things out. No, we don't want to do that. Whenever we're simplifying fractions like this, we want to do as much factorizing as possible. So, x squared plus 8x minus 20. Can we factorize that? Well, do we have two numbers that multiply to give minus 20, but add to give 8? So 4 and 5, that adds to give 9. 10 and 2, 10 and minus 2, okay, that works. So we have x plus 10, because 10 plus minus 2 gives you plus 8. And we've got x minus 2, because it has to multiply to give minus 20, and that to give plus 8. We've got x squared minus 9. Learn your difference of two squares, guys. That factorizes by the difference of two squares to x plus 3 times x minus 3. And then that is multiplied by, well, x squared plus 3x factorizes to, this one is a simple one. Just take out x as a common factor, and you're left with x plus 3. And then we've just got the simple x minus 2. Now, because things are being multiplied, you can cancel things from any part of the numerators, whether it's in the same fraction or not, with any part from the denominator, again, whether it's the same fraction or not. So we can divide here and here, or cancel that down. And we can also cancel this and this. So that leaves us with x plus 10 multiplied by x. I'm going to put that at the front now. And that's all divided by x minus 3. That is good enough, guys. We are good. We're done. Next, work out the values of x for which f of x equals a third x cubed plus 9 over 2 x squared is an increasing function. Right, what does that mean? What does increasing function mean? It means basically that the gradient is positive. Now, we're looking at gradient, but the function's not a linear function. It's a cubic function. Well, any function that's not linear, actually. We're doing this thing where we differentiate. Okay? And our differentiation symbol in this case would be, well, we could do dfx by dx or f prime of x. This is just the notation that's used for differentiation. Now, when we differentiate this function, that gives us the gradient function. We take the power down, this is 3 in this case. 3 multiplied by a third is just 1. x, and then take 1 away from the power, so squared, plus 2 is the power of the next one, multiply it by 9 over 2, that's going to give you 9, x, and then reduce the power, it gives you 1. So it's tidying that up, that gives us x squared plus 9x. So this is the gradient, the general gradient function. And we want that to be positive, i.e., we want x squared plus 9x to be greater than 0. Okay, so we're essentially solving a quadratic inequality. Now, when we're solving a quadratic inequality, always be prepared to draw a graph. Imagine what this function would be if it were equal to 0. So we can factorize this to x, open bracket, x plus 9, greater than 0. And our critical values are when x equals 0 and x equals minus 9. Okay, just imagine that we're equal to 0. That would mean that it's 0 minus 9. We're going to use this information to draw a graph. So it's a x squared graph, so it's a smiley face going through 0 and minus 9 even. I did that wrong. So, yes, I went nicely through there. Come on. So minus 9 and 0. And we're looking at where it's greater than 0, so i.e. above the x-axis. Where is this graph above the x-axis? That's over here. And then we stopped. And then over here. So notice how that's when x is less than minus 9 because it's to the left of minus 9. So x is less than minus 9. Or, and our symbol for or in maths is that union, when x is greater than 0 because it's to the right of 0. Okay, and that's it for this. So join me in the next 5 a day. Or of course, you can now use this to determine, do you understand these topics or are there things that you perhaps need to practice? Head to Corbett Maths. Love the resources that are used over there. Head over there so that you can get some more practice with any of these topics. Take care for now, guys.